Okay, problem number 2024, triangle sequence. A sequence of triangles is constructed in the following way. 1. The first triangle is a Pythagoras 3, 4, 5 triangle. 2. The second triangle is a right angle triangle whose second longest side is the hypotenuse of the first triangle and whose shortest side is the same length as the second longest side of the first triangle. Okay. The third triangle is a right angle triangle whose second longest side is the hypotenuse of the second triangle and whose shortest side is the same length as the second longest side of the second triangle, etc. Each triangle in the sequence is constructed so that its second longest side is the hypotenuse of the previous triangle and its shortest side the same length as the second longest side of the previous triangle. What is the area of a square whose side is the hypotenuse of the nth triangle in the sequence? Okay. Let's try to make some sense to that. So they say that first there is a classical 3, 4, 5 3, 4, 5 Pythagoras triangle here. And we know that this 3, 4, 5 triangle is a right angle triangle. Then it says that in the next iteration, the hypotenuse of the previous triangle, which is this one, should be the second longest side. The longest side is the hypotenuse, right? So the second longest side should be the hypotenuse of the previous triangle. So here should be 5. And the second longest side, let me see if I can get this done. The second longest side, that is this 4, should be the shortest side of this new triangle. And then we can say, or we can note that the hypotenuse, since this is a right angle triangle, should be the square of times 5 and 4 times 4, because that's how we calculate the hypotenuse. And we're gonna call this, I don't know, b. So we can know the hypotenuse by knowing these two sides, and we can know these two sides because of the previous triangle. If we construct a new triangle, a third triangle, then this value b should be the second longest side. And we can keep constructing this on this way. And we know that the second longest or shortest side should be here. And now we know that it's this way. And then we can know the hypotenuse again. Should be the square, the root square, or square root of b times b plus times. And we can keep doing this forever, so we can know each side of the triangle without any problem. So we are going to make this. We're going to construct this, and we are going to make it in an organized way with matrices. So let's say we have A, and we're going to say that A has 3 columns. The first column will have the shortest side of the triangle. The second value is the second longest side, and the last value is the hypotenuse of this triangle. Each row is going to be a triangle. So the first row is going to be the first iteration, which is the 3, 4, 5 Pythagorean triangle, and now we're going to have to construct the next one. So we're going to say for I equals 2 through n, A, which is the matrix, I and 1, because it's going to be the first value for the shortest side of the triangle, is going to be equal to A I minus 1, 2. And then the same thing we're going to make for this. So what are we making here? We are saying that the second longest side of the previous triangle is going to be the shortest side of this new triangle. And the hypotenuse of the previous triangle is going to be the second longest side of this new triangle. What's left? The hypotenuse. And how we get the hypotenuse? We have to get the square root of the sum of the square of these two sides, right? So let me, I don't, so it should be something like this elevated to 0.5 because it's gonna be a square root, and we're gonna say this a I minus 1 2 square plus the same thing but oh wait, it's not this one, it's this one, right? It's this one. Yes, because we are getting these two sides, I1 and I2, so it should be I1 I2. We are getting the square of both numbers, we are adding them, and then we are getting the square root, and we get what? The hypotenuse of this new iteration. The area should be nothing else that this, oh, than this, because they are asking what is the area of a square whose side is the hypotenuse of the n triangle in the sequence. So they are asking us in this n iteration we are gonna have a square whose side is gonna be this one, the hypotenuse. So if we call this okay, it's gonna have a side with an L length, and the area is gonna be just L times L. Since we know that, and we are just getting it, oh, but we are not saying right now. We know it because we are asking for the nth iteration. The hypotenuse of the n iteration elevate to the square is gonna be the area, and that's the answer. So I hope that makes sense. I hope it's easy to understand, and that should be the answer. Also, I want to show here in MATLAB how it should work out. We just run the script, and then we can see, for example, for n equals 20, how the iteration goes. Okay, so first we have the classic 3, 4, 5 Pythagorean triangle, and then we just copy the sides for the new iteration, and then we calculate. This shows how good is MATLAB and other type of programs, because there should be a continuation from the iteration 1 to make the iteration number 2, and then if you want to make it to 20, you have to calculate each step, which is not easy. It's an iterative process. So if we want to make 100 or even 1000, you have to use this kind of programs. And yeah, you could do more than that. You can get, for example, the area of the triangles if you really want to have them. So for the area of the first triangle should be 3 times 4 over 2, so 6. And then the other one should be 4 times 5 over 2, which is 10. Those two are easy. But when you are getting other values that are harder to calculate because they are square roots of numbers that are not easy to get, then you have to use the program. So if they ask for example, for the 15 iteration, what is the area of that triangle? That's not easy to get, but with this type of scripts or programs, you can get it easily. And it's not that hard, it's actually easy to get, like you can write it in maximum 5 minutes. You could get it even 30 seconds. You really uh, know what you have to do, and you can get more than that, and you can get it in an organized way. That's why MATLAB is so easy to work with, because you can get very organized data. For example, here I'm making a new matrix, and I try to get all the sides of each triangle and the area as the 4 column, and yeah, we're getting something like this. So it's easy to get, it's easy to work with, and it's very organized.